Good morning, students. Myself Balamuli, working as assistant professor in Department of Mechanical Engineering. Here, I would like to share a topic in building components. Can you able to relate this comedy scene with this topic? Today's topic, famous dialogue, building strong basement weak. Yes. Today we are going to see a topic called the foundation. It is the lowermost part of the building or in a civil structure that is in has a direct contact with the soil, which transfers the load from the structure to the soil safely. When it fails to transfer the load, then the building may get collapsed. So there are two different types of foundations. One is shallow foundation and another one is deep foundation. Both has a small variation. Like shallow foundation will, when we dig the soil or when we have a foundation level beneath the earth surface 3 meter, below 3 meter is called as shallow foundation. When it is above 3 meters, it is called as deep foundation. It has various categories. Like shallow foundation, it has individual footing or isolated footing, combined footing, strip footing, raft or mat foundations. For deep foundation, it's pile foundation or drilled shafts or caissons. So shallow foundation, as I already said, it has up to 1.5 meter, not exceeding 3 meters. So where soil layer or shallow depth is able to support the structural load, the depth of shallow foundations are generally less than its width. So first step is individual footing or isolated footing. You can able to see in the right side image, you can see that each column has been separately connected with the soil, not the both the columns are being connected. So it is called as individual footing or isolated footing. The most common type of foundation used for building constructions, this foundation is constructed of a single column and also called as a pad foundation. It is a rectangular isolated footing is selected when the foundation experiences moments due to the eccentricity of loads or due to horizontal forces. Second one is combined footing, that we will have combined the two columns with the help of basement footing, so that the load will be transferred to the columns and to the footings at an equal manner. And it also prevent the collapsion of collapsion of the building with the basement level. So third one is spread footing or strip footing. You can able to see that it is a continuous pathway. It has a continuous pathway to covered with all layers, so that the sand fixed inside or poured inside will not be moved. So the momentum of the soil will be fixed, so that we can able to reduce the load transfer failures. So the fourth one will be raft or mat foundation. Here you can able to see that underwater parking, or we can able to use the underground area when it comes under up to 3 meter. So we can able to use it for car parking or some laboratory spaces, so that the space can be utilized properly, and also it will give a good strength with other types of foundations. Most probably in building apartments, this type of foundations will be utilized. So this is the raw image of this raft or mat foundation, where the reinforcement like steels will be positioned based on the needs of this particular building. The next one is a deep foundation. In deep foundation, it requires to carry loads from a structural through weak compressible soils or it to strong or less compressible soils or rocks at depth for functional reasons. Most probably it will be used for building bridges in between water reservoirs like rivers lakes, or even seas. Pile type foundations. It is one of the foundations which comes under deep foundation. Like it is a type of deep foundation which is used to transfer heavy loads from the structures to hard rock much deep below the ground level. There is more than 3 meters, as already mentioned. So can able to see the schematic or a real scenario picture of this pile foundation. The final is drilled shaft foundation, which will be probably used for building national highways, bridges to for uneven soil areas like applications. So it resists loads from structural through shaft resistance, toe resistance, and also combination of both of these. The construction of drilled shafts are done using an auger. So it can located from ground level within 10 meter to 100 meter, that is from 25 feet to 300 feet of ground level. A drill shaft foundation is not suitable for when deep deposits of soft clays or loosened waters bearing granular soil exists. It also is not suitable for soils where carving formations are difficult to stabilize. Soils made of boulders and other exists. I hope you understand the different types of foundation, shallow and deep, and the classifications of those foundations. Thank you.